uh, we are at the flag event of our course, and now today we are going to explore one new programming paradigm. The other programming paradigms that we have learned while we explored language like C, we had learned structured programming language. When we came in for C++ and Java, we had focused primarily on object-oriented concepts. Now it's time for us to go in for functional programming. Language like C++ could support multiple programming paradigms. Java does not support several of them, not all of them, but then it does support several. Generics is what we had seen. Object-oriented programming is what we had seen in Java. And it's time for us to look into functional programming in Java. So let's start off with this particular very interesting topic, that is functional programming in Java. So functional programming, a new lease of life for Java. Now, I'm not just making unnecessary claims, but it was seen for the last few years with the advent of JavaScript, people had started turning towards JavaScript. Now, JavaScript happens to be a completely different, it was earlier scripting language. Now it turned out to be almost a full-fledged language. People started using for a lot of different stuff. And in web domain, it was very, very popular. And then there were complaints regarding Java, regarding like it is not evolving with time and so on. But then these sincere or genuine complaints were responded by Java, and concept of functional programming, which was becoming a kind of style of writing the code, which every developer wanted to have in every programming language, was also adopted in Java. Now, if people complain that Java has been late to introduce this particular concept, they are mistaken. Although Java as a programming language may have been late in adoption of this particular concept of functional programming, but Java as a technology, the JVM that we are working on, has a support for functional programming for a very long time. That means JVM based languages were, even before Java, functional. And in giving you this introduction, there is a reason behind it. So we need to know a bit of history and to understand why when people complain that Java was slow to introduce this particular concept, Java was definitely not slow. Java has made one promise to all of us as a developer, and we should be thankful to Java regarding that. The one promise that Java has made, and it has kept by that particular promise, is 100% backward compatibility. Now, to support this particular functional programming in Java, Java could have introduced this particular concept very long back. The reason for that is JVM was having support for this thing, or JVM based languages like Scala and other things were having support for functional programming for a very long time. So it was not difficult for them to introduce this particular concept in Java. The reason was, if this particular concept has been introduced, it shouldn't have broken any code that was written previously. So even an application that was written previously, and I call the new implementation for the same function today, which is functional, Java has made a promise and has kept the promise. So even with this functional coding, the previous collection frameworks and nothing breaks. So to ensure that 100% backward compatibility is there, and with this introduction of new concept, the previous Java code do not break, it took them a lot of time. It was a big challenge. It could have been easier for them to give a new version of Java, not concerned with what else was there previously, like what Microsoft does, and say, oh, on this new version onwards, it supports, and the previous versions, we do not know about it. It could have been very easy for the creators of Java. Even with introduction of this particular concept, even if you use a new API, which is a new implementation of the same API if you use, and if the newer one is functional, even then the previous code will not break. Even if you had written that code, maybe in Java EC 5 or 6, your APIs will not break. Now that's the beauty of Java, 100% backward compatible, and they have kept that particular promise. So let's quick start and understand what this particular functional programming is all about. The moment in Java EC 8, this particular concept was introduced. As far as the popularity of Java goes, it had seen about 2 to 3% point improvement in the enhancement in the popularity of Java. So when we talk about these indexes, which keeps a track as to which language is how much popular, how many companies, how many industries, how many developers are adopting this particular language, it saw a substantial gain. Again, it regained substantial popularity with this particular introduction of functional programming. And it is very interesting. And it's not just interesting, it's not just a syntactical sugar. It actually is a boost in terms of performance as well. We'll understand what it is all about. So Java is a language which is constantly evolving. or it's a technology that's constantly evolving. It is not the same what was there 25 years back, and today if you say it's the same Java, you're mistaken. It is constantly evolving. Changes to Java IC 8 are many ways more profound than the changes that were ever made in the history. Why are we saying that? Earlier, the other bigger change that happened was in Java IC 5 when this collection frameworks, concurrency packages were introduced and so on. So that was a good change. But this was not a fundamental change in the approach we write the program. With Java IC 8 and with Java IC 9 also, with Java IC 9, the mechanism of packaging the application completely changed, deploying the application completely changed. Till Java IC 8, right from day one, the way we deploy application was exactly the same. With 9, with our concept of modules, that changed. So that was a fundamental change in how applications are deployed. But then how you can develop application in Java, there we saw a fundamental change with Java IC 8, with this introduction of concept of functional programming. The good news is that changes enable you to write programs easily instead of writing verbose code. The basic objective of functional programming, the kind of technique that has been introduced, is you write less number of lines. There is a shift for amongst developers which you are seeing towards Python. People are saying, okay, in Python I need to write less number of lines of code, so let me shift towards Python. Even if I'm compromising the performance, let me shift towards Python, because less number of lines of code means less number of lines to debug. Less number of lines to debug or less number of lines to write the code means less chances of you committing a mistake. Correct. So maintenance of the application, development and less number of lines of code means development is faster. So these were a change that was happening. People do not want to write too many lines of code. They want the same statement to do more. That means less number of lines of code and doing something more. That is something, or I'll put in less efforts and I want something more. That's the kind of trend that we have today in every aspect of our life. And Java developers were no exceptions. They were also expecting the language to do more with less efforts. And it has kept to that promise. This need was felt to have a declarative style of coding wherein you do less and Java will do more for you. So we talked about evolution of languages or evolution of the programming paradigms, the way we started. Earlier, we used to write machine level codes where everything may be in kind of zeros and one, and zeros and ones were so very difficult for anybody to understand. So if you write something in zeros and one, you need to be very good in electronics and then possibly in programming as well. Then you will be in a position to write and handle those kind of machines. Gone are the days. These were early 50s and early 60s. Late 60s itself, the trend was to move from the binary format, zeros and one, to assembly, where we came with mnemonics, move, push, pop, kind of commands which came in, add. Okay, and now those things made it very easy for you to write a code, to express your logic. So that was one major shift that we saw. And from assembly, now people started finding assembly also very difficult, came in this procedural language like C or a Pascal. Now where there were English-like words which were there, which actually made it more meaningful, more than the mnemonics what assembly language introduced. So there were concepts like functions and everything which was encapsulated. We could not see the detailed implementation and it could do more. If I just say print, it could do a magical thing for me. Printf, it could do a magical thing for me of printing a lot of things onto the console, not bothering about what all other operations have been done. So it was doing more with less number of lines of code. If you're asked to do the similar kind of work in assembly, that will take a lot of lines of code that you need to write, especially if the values of the variables were to be substituted and then the strings to be printed and so on. Came in this concept of procedural language. And procedural language ruled, and even today we find procedural language still being in use, or procedural language concepts being used. The selection construct, the looping constructs and everything. So very easy for anybody to express themselves and write the business logic. But then came 80s, we realized for complex application, that particular concept, that way of writing the code is not good enough. And then we were forced to go it with a new style of writing the programs or designing the program that was object oriented. And for last 20, 25 years or more than 25 years, it came in around mid 80s. So if I talk about mid 80s, it's almost 40 years this object oriented programming has survived. Now it has survived for this 40 years. That itself indicates the usefulness of that particular thing. But it is useful, that's true. But isn't it a lot of pain for you to write those code, so much of code that you need to write, design the classes, then create an object, then call that particular function and so on. So there are a lot of efforts that goes into it, a lot of rules that one has to keep in mind. Need was felt to have something where you are not required to specify both what is to be done and how it is to be done. How about writing a code which is easy to read, or not requiring you to go through lines of hundreds of lines of code to understand what is that particular program doing. Need was felt to have a declarative style of coding. What we have been doing till now is a technique where where we actually specify both what is to be done and how it is to be done. We take unnecessary responsibilities while we write the program. Now the APIs have matured to such an extent we can rely on them and let that thing do a lot of things under the hood at the background. And when we write a code, we'll write a simplistic statements which will be very easy for anybody to read and understand. So need was felt to have a new style of writing code. We call it a declarative style of writing code, which is nothing but something which was introduced by this functional programming. And it's not just Java. Most of the languages have transformed with this. It is Java, C++, all of them have seen such kind of transition. C++ was object-oriented. C++ is an exception to all the languages because it supports all the programming paradigms. While Java supports object-oriented, now it has matured from object-oriented to functional style of coding as well. So what exactly is this functional programming? Functional programming is a programming paradigm. That means it's a style of writing the code. It's a design. It's a way we express our logic. It's a style of building structure and elements of a computer program. So all these are different programming paradigms. The procedural language or procedural techniques, object-oriented techniques, and this functional programming or even generics. They're the kind of style of writing the code, style of building the application and so on. Functional code is characterized by one thing, absence of side effect. Now, this is something very, very critical, absence of side effect. That means while we carry out an operation, just to put in simple words, it's something like this. Absence of side effect means it should not, suppose if I pass some data to a function and that function is supposed to carry out operation on the data and give you some result. While it is carrying out operation on the data and giving us a result, it will make you one promise: the data that you have supplied as input will not be altered. So there will not be any side effect on the inputs that you supply while the transformations are happening. So here it will focus more on immutability. So you are assured that the transformation, unnecessary transformation changes in the data will not happen while operations are being carried out. So the major focus over here is that of immutability. And if you can understand this immutability, then you design your, write your expressions, logic, that will be far more easy for you to implement this particular concept of functional programming. But what it guarantees on its own is immutable. That means data that you send will not be transformed, although you will get the result. And result will be a new data set that you'll get, but the original data set that you have supplied will not get transformed. It doesn't rely on data outside the current function and doesn't change the data that exists outside the current function. That means whatever data structure that it builds inside the function and it returns, that's the only one that will modify. What existed outside the function which you have supplied to the function as an input, it is promising you it will not be altered. So you call any function, you pass any data, the data that you have passed will remain unchanged and you'll get the desired transform data if you want. That transform data is also something that you'll get. But the original data that you have, that will remain unchanged. So there will not be any change that will happen to the original data that we have. And that's a promise what functional programming provides you. Just give me a minute. So this is something that you have to keep in mind. While we write all these programs and functional programming in any language, it's not just about Java. Functional programming, when we perform, it is primarily built on this concept of immutability. That the data that exists outside that particular function or outside that particular instruction set, which are carrying out some kind of transformation, will not be transforming the data. Rather, it may appear as if the data has been transformed, but whatever data set that you supply, it will consume that particular data and generate a new data set. That means original data will remain as it is, and the transformed data set will be the new data set that you'll be getting. So any data that exists outside that particular function will not be transformed by this particular piece of code. Then why do you need to go in for this concept of functional programming? Okay, why there is such a demand and people are shifting towards this particular. Now, one more word of caution, it's not like everything is becoming functional. There are appropriate places where we can use functional. Today's application, when we develop, it will be a combination of procedural, object-oriented, functional, everything. So you have to identify which section of my program or which part of my application will be designed in what kind of way. There is not like end-to-end 100% functional. Now, that's not something which is possible. To write good concurrent program, remember we have just now finished with this concept of threading. And the biggest problem in threading was concurrent access to a piece of data. And there is where concept of thread safety came into picture, because more than one thread can operate on the data, and when they operate on the data, inconsistencies can creep in. Whereas here there is a promise that has been made. The input data will not be transformed. But at the same time, you'll get whatever output is expected that you'll be getting. So now all your responsibilities have been taken care of. That means the biggest problem in multi-threaded applications, concurrent applications, was inconsistencies that creeps in because of concurrent access to a piece of data. Now, even if there are multiple code blocks that you have written and both of them have been written in functional style, and the promise that they're making is they're not going to transform the data that comes to it as an input. They will generate whatever output you would like to give, but input data will not get transformed. That takes major problem, takes care of major problem that we face in concurrent programming. So functional programming gives you a right principle to think about concurrency, and it has spawned several high-level concurrency abstraction that makes your job easier. The basic idea, the basic reason why it becomes easier is because the promise that this particular code makes, and the promise it makes is it's not going to transform the data. It will generate the new data. That means it's like if we take a list and I wanted to transform the list, but it will take the input list and generate a new list with the transformation as such. So the original list remains intact. So there is no question at any particular place your concurrent access की वजह से the inconsistencies happen. Two multiple threads carry accessing the same piece of data. Those problems are taken care of. Most programs are just data management programs. If you look at real life, when we develop application, this is precisely the case. Working directly with fundamental collections of data minimize overhead of working with object models while still avoiding duplication and promoting reuse. Because in most of the application, there will be some data that we need to organize. There is some data that we need to fetch. There is some data that we need to modify. These are basic operations. So most of the application that we develop are all nothing but data management applications. That means there is some data which we read, we fetch some values, we display some values, and so on. So if this is what has to be done, and if this is promising you in less number of lines you can get that work done, plus your original data it is promising while that operations are happening, there is no transformation, there couldn't be a safer or better mechanism than functional programming. Functional language provide core set of common data structure with combinator operators that are very powerful for working with data. With combinator operator. Now this combinator is something which is very, very powerful kind of feature which is available. Say I have a list of students and the students have secured some marks or in a particular subject and in various subjects. I'd like to take the total of those marks and then proceed further. For every student, I would like to carry out similar kind of operations. So I'd like to accumulate that particular mark. I would like to find maximum amongst them. I'd like to check who are the students who have secured distinction, who are the students who have failed or whatever it is. So for you to carry out those operations in the data, there are inbuilt functionals like predicates and combinators and the results to be converted to set or to list, to list and to set. There are ready-made features which are available. So as far as various operations that like to carry out on data, there couldn't be anything better than what this functional style of programming provides us. Our objective will be not just to understand these combinators and various functions that functional programming provides you to handle or operate on the data. Our basic will be to understand how to write the code as well. So I'll take a lot of examples. So this topic will be all discussed only with the help of examples. So we'll take up some simple examples. We'll also go ahead with some basics. That is a prerequisite for writing functional programming, because it's long time back that we had seen what is a functional interface, and then what are anonymous classes or anonymous method objects being returned and so on. So we'll do some basics revision and then we'll go ahead with functional programming. So we will be ready with the prerequisite that is required for this kind of thought process. It's a different way of writing the program. It's a different thought process as to how do you build applications. Functional algorithm emphasizes on declarative structure, immutable values, and side effect free function. Three things. Declarative structures, that means we will avoid specifying how to do it. We'll rather specify what is to be done. Immutable values, that means we'll avoid transforming the data. And side effect free, that means you're not going to print something or something like that. No transformation in the environment where that particular function is running. So these are some fundamental features of functional programming. I have to work faster and faster. Development life cycles are going asymptotically to zero length. That means we would quickly want to give new releases to an application that has been developed. We develop an application, the release is like within next 2 days, next 3 days. And there are applications where we find new versions are to be released every few hours. There are some websites where you will find the new release comes every 2 hours or 3 hours. Now, these are the kind of production development cycles that we have, and we quickly want to give some new improvements which are there. In traditional style, if you want to do some change, it will be like you make a lot of changes, you debug that code, maintain that code, you build it again, and then you release that thing. Now that's actually becoming very difficult. We like small changes here and there I make, and I give a new release in the market immediately. Today, for most projects, understanding the domain precisely is less important than delivering some value quickly. The basic idea is like, I'll deliver, and while the applications are still being in use, I'll keep on improving that particular application. So I'll not have new release every 6 months or every 5 years. No, I'll have new releases maybe every week, maybe every day, and so on. So it's the focus is not like creating something which is 100% perfect, which will cater to your requirement for another 2 years. Now you may be wondering, why is that change in thought process? Why wouldn't you want to develop a software which will cater to your requirement for another next 5 years? The reason for that is, no point in thinking for that period of time. 5 years is a pretty long period of time nowadays, because if you think about 5 years period that you're going to design a software and give a client and tell them, okay, now this takes care of your requirement for 5 years, those days are gone. The market is so very dynamic, requirement keeps on changing, government policies keeps on changing. So if you are designing something today, we are not very sure whether it will be required tomorrow or not. The requirements may change tomorrow. Requirement may change, and that could be due to external factors. You are forced to bring about those changes. Now, if that is what is happening, the market is dynamic, it's constantly evolving. So focus is not on developing something which will last for years. Focus is on taking care of your current requirement. If I can address to your current requirement and give you something that will currently fulfills a requirement, or newer requirement that comes in, I can add it to this particular thing, and it can continue to fulfill your new requirements also. We need to rethink the way we keep our code minimally sufficient. That means should have bare minimum things which are required to take care of your current requirement. Don't think too much about what will happen in future, because nobody is sure today what will happen in future. Things are changing drastically nowadays. Now, if the models are completely changing, no point in building something and making an assumption that the same kind of requirement will exist for next 5 years or 10 years. 1 year is also too long a period of time for us to think about nowadays. So minimally sufficient. So we think the need is to rethink the way we keep our code minimally sufficient for the requirement for today, yet flexible for changes. Two things: a requirement for today and flexible for changes. That means it should not be difficult for us to modify those things. It should not be like object-oriented concept where the classes, once I change, then it is going to have a lot of side effect. No, functional programming will actually help you to fulfill that minimally sufficient kind of design. So you will write code which will just take care of today's requirement, and it will be that simple that tomorrow if the requirement changes, I can actually modify that piece of code, and that will cater to the new requirement as well. So I am not boasting about saying there are release cycles every hour. There are organizations which gives you new versions of the product every hour. That means they'll give you 10 different releases of the same product. Now this is the kind of life that we are into. Earlier it was like, if I have one version of the software today, maybe 1 year down the line, 2 years down the line, we'll get the new version. Here every hour they release new versions. Now if release cycles are going to become so short, if I'm developing an application, I'll just take care of the current one. I'll not think about एक हफ्ते के बाद क्या रहेगा. एक हफ्ते के बाद शायद the software may not even be in use. So that's the reason we need to learn and master this particular concept of functional programming. What are the basic principles of this functional programming? Avoid immutable state. Now that's something which is very, very fun. Avoid mutable state, not immutable. Immutability is the core of functional programming. Avoiding mutable state. Some of the most difficult bug to find in large system occur when the state is modified locally by client code that is located elsewhere in the program. That means you call some functions and that functions carries out some change in the state of that particular object, and then you are wondering who carried out that change. Because in Java and every languages, when you pass a reference, you have a permission to alter the object which has now been passed. So anywhere that reference is available, they can bring about a change. And in multi-threaded application, it becomes all the more difficult for us to keep a track whether that particular thread, which thread carried out that particular change. If you make your value immutable, the synchronization problem disappears, because the data that you're supplying, nobody is going to, all of them are going to read the data. Nobody's going to write to that particular data at any particular point of time. So if you are writing a multi-thread application, problems are taken care, because consistency ka problem, you don't even have to worry about it, because all of them can only read from the data. They cannot go ahead modifying that particular data. So it becomes very easy for you to write a multi-thread application by using this particular concept of functional programming. Encapsulating mutation is in well-defined areas and keeping the rest of the code free of mutation improves the robustness and modularity of the code. So we will identify few functions in a program where it will be clearly demarcated. These are the only places where changes happens to the data. Rest all places wherever operations are happening, we are going to make a promise in rest all parts of my program, nobody changes the value of the data. So just kind of differentiation we'll have. So we'll very clearly demarcate those kind of areas of my program which I have a permission to modify the state of the data, and rest all are only reading the data. Nobody's going to modify that particular data. So tomorrow if something happens, we can immediately find out where exactly things are going wrong, or which is that part of the data which is altering the state of that particular object. So maintenance of this kind of application becomes very, very easy. Just yesterday we are talking about in Python, same topic. Some of you are there for Python as well. Functions over here are first class citizens. Now when I say first class citizens means what? Your variables are first class citizens. Why? Because we can assign them to a variable, we can pass it to the function, we can return it from a function. If I take normally a variable of any type, if I take variable of type integer or variable of type character or object of some type, I can pass objects to a function, I can return object from a function, I can store objects in a data structure, means in our collection framework. Today with function programming, we can do all those things even with functions. You can bind functions to an identifier. That means we can assign a function to a variable. You can store your function inside some data structure, inside some collection, list or a set or what, a dictionary, whatever it may be. In here, we don't have dictionary, we have map or whatever it may be. You can, we had dictionary in Java. Nowadays we use maps. You can pass a function as an argument to a function call. That means we are giving a call to a function, and instead of passing normal data, what will pass to that particular function is another function. You can write a function that returns a function. That means whatever you could do with your normal variables, all those things can be done even using functions. And what you see at the bottom, that's the magical stuff that's going to make this thing possible. The symbol that you see at the bottom, that's nothing but the new power that Java SE8 provided to Java, the release 8 provided to Java, that's lambdas. And we are going to master this particular concept of lambdas, and we'll understand how powerful it is and how does it make a functional, a first class citizen when it comes to the Java domain. We have something called as higher order function. Now Python has support, JavaScript had a support for it, Clojure and Scala, they had a support for it. Java also now has a support for higher order function. These are special terms for function that takes other function as an argument and return them as a result. That means a higher order function is a function. The parameter passed to that particular function is a function, and it also have permission to return the function from that particular function. That means there is a function whose return type will be a function. It can return any function. Java methods are limited to primitive and object as argument and return values, but we can mimic this feature with our functional interface. Normally, when we write a function, we can pass some integers, we can pass some primitive type of data or object type of class type of data, and it can return only those objects, and it can return only those primitive type of values, functions. But today, we can pass a function to a function, and we can also return a new function from a function. That means it can also construct new functions on the fly. Every time I call it, construct a new function and supplies it to us. Something like this. Higher order functions now can be constructed in Java. And that's the basic principles of functional programming. So functions are first class citizens. You can assign them to a variable, you can store them into a data structure, you can pass them to a function, you can return them from function. And what we are doing is we are building higher order functions. Brings us to this particular exciting features of lambdas and closures. Lambda expressions are complex way of passing around behavior. Passing around behavior, now it makes our designs of the design patterns implementation also completely changes. So if you are aware of this functional programming, the way we implement some design patterns, that also will change completely. Especially now what reminds me about is a strategy design pattern. If I go on to implement a strategy design pattern with lambdas, life is much more easier than those horrific kind of combinations of interfaces and abstract classes that I have to keep in track to implement that particular pattern. And with lambdas, it becomes all the more easy. Here we say we have an opportunity to pass the behavior around. Behavior is what? Code block. That means we have a function that's a code block, and we can ship that particular function. I can give that function to some function. That means I can pass that behavior to somebody and let that thing being used. And that is possible by assigning a function to a variable, and that variable moved around here and there. So you can pass that variable anywhere. Wherever the variable is passed, there the functionality has been passed. Closure is formed when a body of the function refers to one or more free variables, variables that aren't passed it as an argument or defined locally, but are defined in the enclosing scope where the function is defined. Now, those who were there with me yesterday, this is precisely what we had seen. A closure. We are discussing the same feature even in Java yesterday, even in Python yesterday. And same thing is available here as well. So what are we talking about? We are talking about a behavior where there is a function that has been defined. Listen to me very carefully. There's a function which has been defined. Where has it been defined? Inside some other function. Normally, a function has a permission to access the variables which have been defined inside its own scope. But this function will not just access the variables which have been defined in its own scope, will also access the variables which have been defined in its outer scope. That means the enclosing function. Story doesn't end over here. Story doesn't. You may say, so what? Normal function also has a permission to access the variables at a global scope. Yes or no? So if I have a function, this is my one function, inside which there is a sub function. For it, this upper one is the global scope, enclosing scope, outer function scope. You may say, sir, regular function also can access the variables which are in the global scope. So what's so special about a function which is there inside a function accessing the variable of its surrounding scope? There is something special over here. When the function returns, outer function returns, all the variables are destroyed, but this inner function can remember the state of the outer function's variable. Now that's something very powerful and something unimaginable that we can come across. So that is something which is closure. So we can have this concept of closure where the inner function remembers the state of the outer function when it was called. So I can have different versions of the same inner function that I can get. And that's what we are going to learn, lambdas and closures. Closures where a function has a permission or a function has an ability to remember the state of its outer function, parent function. Parent child is not the right word, but I hope you understand. The inner function and the outer function. So you hope they remember the state of the outer function even when the execution of the outer function is over. Normally, once we return from a function, everything is destroyed. How about you remembering the variables of the outer function? The function is not running. How long do the variables of the function exist in the memory? The variables in the function exist in the memory as long as the function is running. So how about remembering the state of the function after the function has been returned? And we are not talking about global variables. We are not defined global variables. We have our regular variables only and the local variables inside a function, and the inner function will remember the state of that outer variable, outer function's variable. That's something which is possible by using functions. So you can have different versions of the same functions. And then something very, very interesting, a lazy and eager evaluation. In programming language, any instruction that I write, and if I call that particular function, we are assured that function will get executed. Correct? So that's eager. That means when we reach that particular statement, when we call that particular function, every instruction that is there inside it has to get executed. Lazy evaluation or call by need is an evaluation strategy that delays the evaluation of the expression until the value is needed. So it doesn't mean that if you execute that particular statement, that code has to get executed. It sees, are you using the result of that particular statement? If you are not using the result of that particular statement, it will not even waste its time calling that particular or executing that particular function. It will delay the execution of the function till the time it doesn't come across a understanding that you are using the result of that particular function. Now you may say, sir, using the result of the function is a different case, but if the function is carrying out some transformation, then in functional programming, functions are not supposed to carry out any transformation. Data is immutable. So there is no question of mutability that will come into picture. So normally what we have been saying is we call functions for 2 reasons or 3 reasons. First, for its return value. Second, for its side effect. And third, for both return value and side effect. In functional programming, we never call function for its side effect. So no side effect. We may call that function for its return value. That is possible, but no side effect. Now, if it's not going to have any side effect, then why do I call, if I call a function, if the function is not supposed to print, not supposed to write something to the database, so no side effect. That means we are calling a function only for its return value. If the return value is not being utilized, then it says no point in executing that particular function. So that is something it can identify. We do not, even if I have written a code and the result of that particular code is not being utilized, it will delay the execution of that particular code till the time it doesn't realize you're utilizing the result that the code is returning. The opposite of this is opposite of eager evaluation, where expressions are evaluated as soon as it is bound to a variable. Normally, if I say x is equal to something, that expression will get evaluated, answer will get stored into that particular variable. That's eager. That means you're binding it to variable. That means the result is now being used and stored inside a variable, and you plan to use that variable. So that's eager. Execute it immediately. Here we'll see the difference between both of them, eager and lazy evaluation. It relies more on lazy evaluation. If it realizes the code that has been returned, result that has been returned is not being utilized, it will delay the execution. It will not execute that piece of code just because you have asked it to execute that particular code. That brings us to the difference between declarative and imperative style of coding. What we have been doing till now in object-oriented programming is nothing but imperative style of programming, wherein we have been specifying every minute detail as to how that operation has to be done. Every place we have been specifying not just like what is to be done. We are not just specifying what is to be done. We are specifying both what and how. That means what is to be done and how it is to be done. Logic is also specified by us. With functional programming, we actually move ahead toward declarative style of coding. And in declarative style of coding, we'll not worry about what We'll not worry about how, we'll only worry about what. We'll only specify what we should be performing and not worry about how it should be doing. That how will be hidden, how will be taken care of by these APIs for us. So even if I have to apply a function to carry out some kind of operations, maybe some conditions to be applied or something like that, you just specify the condition. It will take care of how to do that. It will manage how to construct a list and those, how to return the list, how to store the values, add them together to append. It will do all those things automatically. So the focus is on, while you write the program should only specify what is being done, should not give details as to how it is being done. So that's the major shift that we have to bring about in our way of writing the program. The style of writing program will change significantly when you use this declarative style of programming. Significantly, there will be a change how we write a program. There are a lot of interfaces that I'm going to introduce you to. And this is not all, but then these are something that you have to be aware of. In the process, I'll come across few more interfaces. And then we need to understand where and how these interfaces have to be used. As the name says, predicate. Predicate means some conditions. There can be unary predicate, there can be binary predicate, there can be some predicate. So there are some interfaces which are predicates, which will allow you to specify the conditions. There are some consumers. Consumers, as the name says, whatever data that you have supplied, they will be consuming that particular data. There will be some functions which will specify what operations have to be done. There are some supplies which will generate some values and give it to you. There are unary operators, there are binary operators which will give you an opportunity to specify what operations you would like to perform and so on. So all these interfaces, we have to have very clear understanding, and we should be in a position to read the code where which particular interface is coming into action. So we'll talk only in terms of interfaces. In this entire coding, we'll talk only in terms of interfaces. Implementation can change at any point of time. So we said another beauty of this particular codes are, we should be in a position to make quick changes. It should be easy for us to modify. And that makes possible because we are going to code for interfaces, not for a specific type. So maintenance of the code also becomes easier. Updation, making out changes is very, very easy. So that was a basic introduction to this particular concept of functional programming before we actually go ahead with a lot of exercises that will demonstrate how we can go ahead using them. Bhushan, okay, if you understood what you have discussed till now, please click on yes. Bhushan, what was your request? Go slow? Was it what, that is what you are trying to tell me? Was I fast? Oh, sorry then. You could have unmuted and asked me. Anytime if it so happens, and I agree, I know I at times go fast, just unmute yourself because I saw your request very late. So in case if it is like you cannot keep up with what I'm saying, at times it may happen. I have been told by my staff also, sir, sometimes you speak very fast. Just unmute yourself, make a request. I'll repeat. Is there anything that you missed out and you want me to repeat? Okay. Okay, that's okay. Good. I was expecting your other friends also to join in today. Pardon?
So, can you just repeat the closure part?
Okay, I'll just explain you. Closure, I'll tell you, simple thing. Closure is a concept. Normally what happens is when you call a function, what happens when you call a function? You call a function, the function gets loaded, the variables are created. When you return, the variables are destroyed. So how long is the information that is stored inside the function retained?
We come out of the function and everything is destroyed.
Only till the time the function is running. The moment you come out of the function, everything that was stored inside, that the state of the function is lost. Yes. Now here closure will give an opportunity, because what kind of opportunity? There are functions, there is outer function in which there is an inner function. You give a call to the outer function, you cannot call the inner function. You give a call to the outer function started executing, it had some variables, those variables were referenced in the inner function, and you are returning the inner function, and amongst the several variables that were defined in the outer function, their state will be remembered by this inner function that has now been written. So we are returning an object, a function object that will remember the variables which were there in the outer function, their state it will remember. So it will, and I can have more than one versions of the same inner functions, and I'll be discussing it as I go ahead. But point is, the inner function will remember the state of the outer function. That means even after the outer function has finished its execution, the inner function will still remember what are the values of the outer function, values of the variables of the outer function.
Everything is closure, or the inner function which return is a closure.
Pardon?
Closure is the function, inner function.
No. Closure is a
Or the
concept.
conduct
Closure is a
itself.
concept where we are in a position to remember the state of the function even after returning from the function.
Okay. Okay, sir.
Okay. And how is it made possible? It is made possible by returning a function from within an outer function. And that inner function remembers the state of the outer function.
Okay, sir.
So this was a brief introduction to this particular concept of functional programming. It's just an introduction. And today what I'll try and do is do a revision for you, because it always happens that some fundamental concepts, key concepts we do not recollect, and then it becomes difficult for us to read. Our major objective over here in functional programming is at least we should build our ability to read functional code, at least. And once you start reading that code, then you can build the code. But if you cannot even read the code, forget about you writing the code. So let us take a lot of examples, start from the very basic, some basic concept I'm going to revise, which one needs to remember if he has to write functional programming. So let's start with some basic concept. Give me a minute, I'll just open up write examples for you, where you will start right from scratch. Let's begin with a demonstration. Now, first is like when I'm talking about this functional style of coding and declarative style of coding, it's not totally new for us. It's like this kind of support is being available, but what is the major change that we need to bring about in our thought process about writing a program? That is what we'll try and focus on. And then I'll take an example, several examples in fact, wherein I'll try and explain you every aspect and every API that interface that is at the core of functional programming in Java. So let's begin with one very simple example. And you're going to tell me how would you go ahead implementing it when you have been put across similar kind of requirement. Now there is a list that I have. No, it's a array of strings. I have an array string called as cities. That is a string that I have. And I wanted to know whether inside this list of cities or inside this array of cities, do I have a city named Nasik or not? So this is an array of strings, and I wanted to know, do we have a city called as Nasik over here or not? That's a simple requirement that we have. How would you think about solving this particular requirement? I don't know whether we have a city called as Nasik over here or not. I have an array of strings, and we have been told inside this array, see whether this number is present or not. See, I have taken array of strings. I can have array of integers. So there are 100 integers that I have, 100 unique numbers I have, and I'm asking you, or 10 numbers I have, and I'm asking you, tell me whether number 7 is present inside this array or not. How would you go about it? Anybody? What kind of program will you write to fulfill this requirement? Come on, how simple it can, any simple it can be. There cannot be a question which is simpler than this.
Loop inside it.
Louder?
There will be a for loop and then if condition, checking if the data
Correct.
is matching
And the for
with
loop
the
will iterate
content.
from?
Start till the end.
0 to
of the size of the end.
Okay. And then you can bring about some improvement. Do you always have to go till the end?
no.
No, then?
If we find that element, then we should break.
We should break and we should stop. Okay. So many of you have made an attempt, and that's typical programmer who comes from the C background, the C++ background, where he has done object-oriented programming, where he has done the procedural programming, and he has that imperative style of coding in mind. Now you have to graduate. You have to solve this particular program in a different way. If you're a functional programmer, and I bet even others who have not answered, a lot of them are scared to go wrong. Yeah, I keep on repeating. Fear of failure is the biggest hurdle for anybody's success. Huh? So if you fear that I may go wrong, how do I tell? This is the only place where we can fail, where we can go wrong. All of us know each other. Doesn't really matter. It's much riskier to fail in the real world. So you need to test. This is an opportunity. When I ask you a question, I keep on telling you, when I ask you a question, it's an opportunity for you to open up, to speak. Tomorrow you have to speak to your team members. Tomorrow during the interview, you have to speak to a manager or interviewer. And if you don't have that courage to speak, then people panic. Even if you know you cannot speak it out. I knew it, but I couldn't explain. Now, these kind of excuses we cannot give in our life. So when I ask a question, there should really be a competition between you who will answer. You should have raised the hand. I should have said, okay, everybody wants to answer. Now Gauri answer because she has raised a hand earlier or something like that. So take it as an opportunity. We rarely get an opportunity to talk about some technical stuff and so on. So take it as an opportunity, because if you are good, you are appreciated. If your answer is right, you are appreciated. If you are wrong, then also there is nothing to lose. You know what is the right one, because then I am going to tell you, somebody else is going to correct you. In either way, even if your answer is right, there lies a benefit for you. People will get a good impression of you. Even if your answer is wrong, still it's good, because you are going to benefit out of it, because you're going to get the right answer then. Otherwise, even today, when I had a meeting today in the morning, and there are some fundamental queries in my mind, even regarding C++. I took it on to the forum. I discussed it with my seniors. Why is it so? Had I not discussed it, I would not have got a clarity whether what I'm thinking is right or not. Cannot be judged only by reading the books, because when I read the book or anybody reads the book, it is our interpretation of what the author has to say. But when we are across the author, then can we not ask him, "Arey Baba, ye kya keh rahe aap? Is this what you want to say? Because this is what I understood." If he says, "Yes, you have thought it correctly," that's a good thing for us. And if he says, "No, Rishikesh, ye galat kar rahe ho, aisa nahi kehna tha mujhe. This is what I mean by this particular sentence." So it's interaction. Why are we having live sessions? Because there's somebody who can help you out, and then there's a community. We all are there to help each other and so on. Make sure you look at it as an opportunity. Our session, Java is on the flag end of our course, but then your learning is going to continue through your life. Don't forget to have that habit of asking questions. Okay. And some of you had that passion, and like Sampada used to ask a lot of questions in the classroom, and surprisingly on internet, she has just disappeared. Sakshi continues. Then Vikrant asks the question. Okay, Pranav sometimes answers the question. He never asks the question, but he answers the question. Okay, but then everybody should ask. And Sakshi Surenshi is good about sending mails. She will ask only on mail. She will not open up her mouth in public. Now that shouldn't happen. Okay, Rajat asks sometimes questions. You have to have a courage to even talk in public. Why only personal discussion only on the mail? I'll do this, I this and that. Everybody, it's not like to pinpoint somebody, but it's just to help you overcome that fear. Just get it off. Doesn't really matter. You have a doubt, ask. Don't worry about what others are feeling about you. Let's continue with our discussion. So we are talking about thought process. And I challenge, most of you have thought what these 2-3 people gave an answer. That is the first thing that came to your mind. You will write a loop that will start from the 0th position, go till the end of the array. No, then an improvement. I'll only search till the element is found. If the element is not found, there is no point in searching. Believe me, you have learned enough of Java by now to do away with this thought process. But then there is so much of, hangover, so that even if I was asked a lot of times, this comes to our mind first. But then you have to curb that particular thing and start thinking in a different way. And that different way is declarative style of coding. And look at this. All of you knew the solution. The other way it could have been done. We did not think about it because we are too very engrossed in taking unnecessary responsibility. Now, what is the unnecessary responsibility that you have taken over here? 2-3 responsibilities that you took unnecessarily. First, somebody told me that you start from the 0th position and go to the last end of the array. And then that was a mistake. No, there was no point in going till the end of the array. That was a mistake that was there. Okay, then you improve. No, I start from the array, go till the element is found. Fine. Array, but start from the array, but the array index starts with 0 or 1. Last element is length, or so it should be less than length or equal to length. So there are so many, and every pass will have to increment that particular counter. If you forget to increment the counter, again there is going to be a problem. You'll go into infinite loop. You'll just keep on checking the first element itself. But whether the first element is 0 or if it's 1, last element is less than length or length of that array. There are so many things that are there. This for loop that we have been writing, it seems to be so very easy, kind of natural thing for us to write, is the most complex piece in the world. Because we have to have the initial value right, we have to have the condition right, we have to have that increment factor right. If you mess up at any of these places, your things are going to go wrong. And galti se 2 baar increment kiya, all the way, all the more it is wrong. And array, what we have right now, okay, is a kind of collection. Collections are iterables, so we can iterate through them. Then why, if they are iterator, they are the iterable, they supply you iterators, they can iterate on their own. Why are we unnecessarily taking the responsibility of iterating through an array where there is a ready-made support which is available for you to automatically iterate through an array? Why are you bothering about whether it starts with 0, where it ends, I++? So something that we find, and there is unnecessary code that we are writing and making somebody responsible for testing that particular code, and then you forget somewhere to increment, you check the condition wrong, less than limit की जगह less than equal to limit कहा, size of the array कहा, 0 की जगह 1 से start किया. There are so many places where we can go wrong. But unfortunately, this is how we think. And there is where I'm going to bring about change in your thought process. So the rest set of examples will be, I'm going to make my best attempt to make you think in a different way, because there is an alternative which exists, and believe me, you are aware of it, just that doesn't come to your mind first. It's not on top of your mind. It's there deep somewhere in your mind. Top of mind, loop lagayenge. I know it and I got the answer. Curb that habit. Don't take up unnecessary responsibilities. Okay, you may be very comfortable writing a loop. Not every maintenance you are going to create a problem. You're going to make somebody's life difficult to understand वो I plus plus लिखा है एक ने और दूसरी जगह लिखा है plus plus I. तो इंक्रीमेंट करते हैं प्लस प्लस आए, पहले इंक्रीमेंट, हाफ ऑफ द पीपल डोंट इवन रिमेंबर. आप प्रीफिक्स लिखो या पोस्टफिक्स लिखो, वैल्यू स्टिल गोना चेंज. दे फील पहले चेंज होगा बाद में चेंज होगा. अरे पहले बाद में नहीं, वो वैसे ही चेंज होगा. सो देयर इज सो मच ऑफ कंफ्यूजन दैट इज देयर. So why bother somebody who is going to maintain the code? He may not be as good as you are in Java, and that's always going to be the case. The next generation will be not putting in that kind of effort to write so much of code, and you're making somebody's life miserable by writing such kind of program. How we could have written? In this particular code, where we had this array of strings, I could have converted this array of string to a list. Don't you know the function called as arrays.asList? We have learned collection framework. We know arrays is a utility class, two utility class that we had seen, collections and arrays. Util, remember that? Util package, collections and arrays. And they provide you so many functional algorithms which are already supplied to us. So I could have converted this arrays to a list and got a list of strings. Instead of array of strings, I could have converted into list of strings. And if I'm like you, we are thinking that fashion, if this is what we had thought about, this is precisely we would end up doing. I could have taken that list over here. I could have taken value false. I am better than you. At least I did not write a for loop. I have taken an atomic for loop. But then by writing this atomic for loop, I have at least taken care of one responsibility. What? Iteration to the loop is not some, iterating to that list is not my responsibility now. This for each kind of loop at least has taken responsibility to start from the right position and go till the right position. At least that responsibility has taken. Zero से start करना है क्या, end कहाँ करना है, array खत्म होने के लिए how do I find the length of the array? Is it dot length is a function or dot length is an attribute? A lot of people even get, and I know most of you have got confused even with that. Should I say list dot length is a function or length is an attribute? Should I put brackets or not? These are unnecessary things that comes to your mind. Even if you know length is something which is there, function था या array का attribute था, याद आ रहा है किसी को? Attribute था. It takes so much of time. So why take up that responsibility? Why not take this for each loop? And we have been using this for each loop from STL days, C++ days, for each element of type string inside cities. Now the cities could be a list of 1,000 elements or 10 elements. We are not bothered. It's going to cycle through all of them. And then every time the city will refer to the first city, Pune, then the Mumbai, then the Aurangabad, then the Nasik, and so on. Every time I will check equals ignore case. I'll also ignore the case while comparing. Who knows how have we written Nasik over there, whether it's an uppercase or small case. So I'm going to ignore the case while I'm comparing these two strings. And if it is found, I'm going to set this variable found as true. I'm going to break. I'll come out of this loop and I'll print Nasik has been found or not found, whatever it is. Now, this was better than what you have specified me, because if I write for I equal to 0, I less than the length and I plus plus, you could have done that. But in that case, you'll have to say list of I dot something equal ignore case, Nasik, and so on. That would have been all the more difficult. So we have used a for loop. For loop uses the implicit iterator. This for each kind of loop, iterate through that particular array for you automatically. But even if you had thought in this particular fashion, I would have given you 1 out of 100. Okay, because there is a much better style of writing the code that we have already learned. But the only thing is, like, we did not bother of using it. If this is, let's see whether it searches for Nasik correctly or not. Does it find whether there is a city called as Nasik or not, whether it runs correctly or not. Let's run this program. It has got executed. Hardly takes any time. Oh, it's still running. let me build this particular code and check whether build is right. Perfect. Let's run this particular program. And it says found Nasik, true. It is there. Fine. So if you are happy with this code, you should slap yourself. Okay. That slap yourself. I remember the one statement that who had made. It was about polymorphic behavior. Okay. Anyway, same thing. Now, if you are aware of collection framework that we have learned in Java, what you should be doing? To get that, to know whether in the list, do you have the city called as Nasik or not? I could have written only cities dot contains Nasik. List interface has a method called as contains. We don't have to bother. It will return you value true or false. So that's a declarative style of coding. It's easy for anybody who doesn't know anything about programming. Maybe your younger brother or your father or mother who may not have learned programming. If you ask them to read this statement, city contains Nasik, is there any chance of they going wrong interpreting this particular statement? And if you ask somebody who is also knowing programming, even to read this statement, they'll take time. Oh, for me to understand what is this particular code doing, I need to check, oh, boolean variable false correctly initialize kiya hai kya? Oh, and if it is false, that means I have to set it over here as to condition dala hai kya, curly braces sahi jagah hai kya? There is so much of testing that needs to be done over here. So even if you write this particular code or somebody, your colleague has written, you're very good in Java, and he's asked you whether this code is right or not, you will still have to spend time reading and understand the sequence of these operations. Unless you have not gone through this 10, 12 lines of code, you will not be in a position to say with confidence whether it's working correctly or not. Tell me over here, do you have any doubt of this not working correctly? Oh, list interface, list was implemented by array list, and where array list has implemented this particular method contains correctly or not? Do you have any doubt? And since array list has a method called as contains, cities over here was my list now. City list was my list over here. It's a list. And this will give me any implementation. Every list has this method interface. We are coding for interface, so we are more bother about the list. And it could be implemented using array list or linked list. I don't bother, because list has promised you there's a method called as contains and contain method. So here what we are doing, we are focusing only on what, we are not focusing on how it is to be done. And here you are unnecessarily taking the responsibility of not just about what, about how as well. You wrote the entire piece of logic to specify how this operation has to be done. So this is unnecessary responsibility that we are taking, and we have to change that thought process now. Take my word, you have to change that thought process. Earlier you do it, better it is, because world is moving towards it. Wherever possible, people will expect to write functional code. Why? Look at the number of lines of code that we have written. Now it's not just about you putting in this efforts to write the code. It's efforts are now multiplied. Somebody will have to test the code. Tomorrow while maintaining, somebody will have to maintain this particular code. So how many times you're going to ask how many people to go through these 10 lines of code? Rather, one line, understanding, maintaining, everything is easier. Does not contain Nasik, contains Nasik. Whatever you would like to do, one exclamation mark here and there will do the logic change for you. Here, if I say does not contain Nasik, you'll have to think, what do I do if I have to check whether it doesn't contain Nasik? Then we'll have to change the logic over here. It's difficult for you to bring about changes. And here, one exclamation mark, because anyway it returns Boolean value, true or false, false, true, you could have done the entire thing. And it's so very easy for anybody to understand. Look at from the maintenance guy perspective. Suppose you are a guy who is maintaining the code, somebody else has written. If you are asked to read this code, and if you are asked to read this line of code, which one is easier? Easier to understand, easier to maintain, easier to check. Okay, and that's the change that we have to bring about. So tangible improvement in declarative way, no messing around with the mutable variables, because here we have passed a list cities. City was a list. I have taken care of making it final. And take my word, while I had asked you that question, in nobody's mind it must have come, I should make that particular parameter also as final. Even if I had passed arrays, you could have received that array in a function, and then if you do not make it final, while I'm carrying out an operation, galti se kahi se element mein null store ho gaya to, that element will be lost. So there is a possibility that while writing this code, the list itself gets corrupt. Yes or no? Here by mistake, if I say city is equal to null, what will happen? Okay. If I'm passing the city and city dot name is equal to something, that means that element, if I want to change inside that array, inside the list, it will get deleted. There is a problem that may happen. Here is there any such chance of happening? I'm saying just cities dot contains. There is no code that we have written. So this is why we should always think about writing code in declarative style, where we worry about what and do not worry about how to do it. Don't dwell into how. Yeah, how bhul jaiye. Just worry about what you want to do. So we will now learn techniques to implement such declarative style of coding. So rely on collections. I have been telling you collection is the heart of Java because collection provides you so many different implementation. Why you end up writing code when collection is already providing you support for those things? So any problem has been given, think about how can I use collection over here, and take my word. Today, there is already a project has been initiated to convert the entire collection framework and make it functional. And by making this functional, it's not just about reducing the size of the code. I'm going to provide you empirical proof that this works faster as well. Okay, it's not just a syntactical sugar where you see changes in the way we write the code. It changed the way the program even runs. So it's not just about reducing the lines of code, it's about improving the performance of code also. And I'll prove it with some examples. And with clocking the speed and everything, we'll see does it really work faster or not. I'll give you that proof of it. So this was, you may think about it, kitna simple example here. It's not about the example, it's about you understanding where we have to bring about change. This is declarative imperative, where we take the responsibility of what and how, and declarative, where we only worry about what. We are not going to worry about how. Did anybody bother about how does list check for and contains, what is the implementation? Although source code is available, did we ever bother to go into the source code? It's encapsulated, it has been hidden from us. Okay, so the code should become easy for anybody to maintain. Let there be a library support. Internally, there are a lot of things which happen. By writing functional code, it's not that code is going to disappear. Somebody will have to put in that effort. So if you create a class, your user need not put that effort. You put in that effort and encapsulate those things and provide in your implementation. So it should make the application very easy to maintain, very easy to debug, very easy to test. And that's the purpose of going in for this functional programming. Less efforts, more work. This is not what I really wanted to start off with, but since we are left with only 5-10 minutes, I'll take an example. And next session, don't miss. Ask your friends also to join in again. Those who haven't made it today, tell them the importance of this particular topic if you have understood one. And take it as your responsibility to help your friends also to master this particular concept. It should not be like, chalo mujhe to aa gaya, chalo I have an age over here, mera placement jaldi ho jayega. Don't have that kind of myopic kind of ideas and views. Help out your friends. Let's have a look at it. I have a class called as calculator. This calculator class has a method which is public, which says operate binary. And what is it doing? It says A and B, and what is it taking it as a parameter? Okay, now these are the kind of coding that we have to master now. It is taking in a parameter which is OP, and OP happens to be an object of some type on which I'm going to call an operation. But what is this integer math? Our integer math is an interface. This is an interface which defines a method called as operation. It's an interface which defines a method called as operation. Now, if it defines a method called as operation, why am I calling it a function interface? Because it has only one non-abstract method, only one abstract method. Okay, there can be other final method, private method, default methods, because function interface is a method in which there is only one abstract method. There can be other default and private methods as well. We know about it. I have a class called as multiply that implements this interface. That means it provides the implementation for this operation method and it will multiply. Likewise, I could have another class which does addition as well. I have another class which can do addition as well. That is again a type integer math, because I can say object of this type is a kind of this type, because subclass object can be referred to as super type object. It has provided methods called as operation. In traditional fashion, if I was asked to perform an operation, how would I go about doing it? I may have this calculator. That's a calculator. That's a class that has a method. Okay, that has a method. I construct an object of that particular class. If I construct an object of the class, I'll have permission to call that a method called as operate binary. But when I call operate binary, it is requiring us to pass 3 parameters, first 2 and another object of type integer math. Now, when I say integer math, we will never have an object of type integer math. We'll have object of some class which implements integer math. So in that case, I could construct an object of type integer math. It's an interface. You never have an object of type interface. You will have an object of some class which implements that interface. You will have object of some class that implements an interface. And then if I say my app dot operate binary, I pass 10, I pass 5. So 10 and 5 are my two values that we are supposed to pass. 10 and 5 are two values that we are passing. And third thing, I'm passing an object. Object of which type? Object of type multiply. So if I pass an object of type multiply, multiply is a kind of math integer. So super type reference can receive it. Super type reference can receive it. So when I say op dot operation, whose operation method is being called? Multiply's operation method is called. That's very correct, because over here multiply object is being passed and it has overridden the super class method, super types method. So it's the multiplies method that will get called, and you will get the method call and you will get the right answer. So it will be like op dot operation a comma b. It is this particular method that will get called, because op over here is now an object of type multiply. Correct. Although this is super type reference points to an object of subtype. Remember, it is not the type of the reference which decides which method is to be called. It is the type of the object to which that reference is pointing to will decide which method is called. So super type interface type reference, if it's pointing to object of multiply, it will invoke method of type multiply only. At compile time, it will check whether math integer has a method called as operation. Yes. At runtime, it will not check whether it has a method. It will check to which class object it is pointing to. Oh, OP is a super type reference. If it is pointing to object of multiply, it will invoke method from multiply class to get that particular work done, and you'll get your answer. Now that's what we all know about. Now what am I doing? And that will be the next topic for our discussion. Next time I'm saying integer addition. I'm not going to write so much of code. I'm not going to write a class that implements an interface and overrides a method, and then I'm going to get my work done. No, I'll go ahead with something called as lambdas. In the next session, I'll help you understand what these things are all about. I'll create a lambda that is a code block that can be assigned. So it's a behavior, it's a function, it's a code that can be assigned to a variable, and that to an interface type variable. Don't worry about it. I'm not discussing in detail, just a brief about it. And next time I'll help you understand how to read it. So here I have created a code block, a behavior. We say we can pass around behaviors. That's what we said in the introduction. So there is a code that has been written, correct? And that has been assigned to an interface type reference. Oh, there is a code that has been written that has been assigned to an interface type reference. When I next time say addition dot operation 10,3, addition is what? Addition is this dot operation 10,3, subtraction dot operation 10,3. I am not even required to have this object. I am directly calling this method called as operation, which is their integer math. So this reference is invoking this methods to get the work done. Does it really work in this particular fashion? Let's check it out. Whether do we get the answer in this particular fashion? I'll explain the working of it next time when we meet. I'll not even start with this example. I'm going to take a different example to help you understand it. But anyway, we are just checking whether does it give an answer. We got the first answer, that is 50. The next answer, that is 13. And if I see this next answer as well, I'll get the next answer as well. Did I run this? Oh, I'm here. If I run that particular code, we'll get the next output as well, 7. So I got that particular answer. It's working. So while this also worked, this kind of code is also working. And this code much more easy for anybody to write and implement. We did not create a new class. Here we had to create a new class that implements that thing, and then you use that particular class. Where is a new class? And think about, I want to perform 10 more operations. Am I going to create 10 different classes? Here for multiply, I created one class. If I said subtraction, which I one more class, addition, which I one more class. Or how many classes you're going to create? You will have an application which is bolted. Too many classes which are there. Packaging becomes a nightmare, because more the number of classes. If you want your application to work correctly, you'll have to package all those classes and supply. I want to bring down that responsibility of packaging as well. Some of them tell me, sir, write an anonymous class. Oh, even if I create an anonymous class, after I compile for anonymous class, also a new dot class file gets created, if you remember. And if no, don't create an anonymous class and see there is a dot class file that gets created. So I want to bring down the number of classes which are available. I do not want for every new operation, a new type to be created. Comes in this very powerful feature. I'm saying my app, and look at this. If I wanted to use in this fashion only, oh, if this was not something that excites you, you wanted to continue with the original style, older way of writing the code, you do it. my app dot operate binary 10, 2, multi. What was multi? Multi was what we had seen earlier. Oh, I could now do it in some different way. I could supply over here addition. I could supply over here subtraction also. I could do something more. I could write an anonymous class. I'll take the revision of this next time. My app that operate, and I can construct new one that is doing operation of addition, or I can use the previous addition as well. And all of them can get the work done for me. So I do not have to unnecessarily waste my time writing the codes. I can get all this work done. And if you really want to understand how is this thing working and how should we design this stuff, don't miss the next session. Okay. So with that, we will stop over here today. This was just a brief a warm-up session to excite you to learn this particular new feature, very powerful feature, just a glimpse that I've given, and we'll do a lot of interesting stuff. This is just the beginning, not even the first step. We have understood what functional programming are. We have understood what we are about to achieve. We learned few important concepts. We understood immutability is a very important behavior over here. We understood state closures. We understood we can have first class variables can be assigned, code can be assigned to a variable. Although we haven't learned the implementation, but what are we going to do? We are going to have a function which can return a function. We are going to have a function in which there is a function that has been returned. So there are a lot of such powerful concepts that we can now go ahead implementing. Okay, so don't miss the next session. We will be starting with right from scratch. The second example that I took, the first example told you how to do it. Second example was a glimpse about what we are going to do it. And we are going to explore all the various new APIs that have been introduced, and they will help you. Those are from DBMS over here. It will help you in that MongoDB and other places also is going to help you. You will understand how it is going to help us. Okay. So it's now most of the languages, they are started appearing similar kind of thing when you are carrying out operation. Even the words, the commands have started appearing similar. So if you learn it over here, tomorrow when, take my word, tomorrow when you learn functional programming in C++, you will be in a position to read that code as well. Because the names are also almost the same, what we are going to learn. If I say predicate over here, if I say consumer over here, if I say supplier over here, you'll have the same names over there as well. So we'll now build a foundation for functional programming. Your fear about functional programming will go off, and you'll be much more confident at least to read and understand. And hopefully you will also be in a position to write that particular code. Okay. So don't miss the next few sessions. I'll make my best attempt to make you very comfortable with this particular concept of functional programming. But that's all as far as introduction goes. Those, again, I repeat, urge your friends, those who have missed out today's session, उनको बताइए attend करें. इसमें जो miss किया हुआ threading नहीं आएगा तो भी चलेगा. They can still understand what we have, this new topic altogether. They will also get benefited. I'll be uploading this video by today night itself. So ask them to go through them. You also revise it if you want to, and be ready for the next session. Next few sessions, we'll be learning something totally new way of writing the program. Nothing to do with C++ that we have done, Java that we have done, total different way of writing the program, what we are going to master. With that, we stop for today. Thank you for attending today's session. Take care. Good night. Love you all. Bye-bye.